Okay, so today we're going to talk about matrices and their inverses. But before we talk about inverse matrices, we need to talk about the identity matrix. Okay, so the identity matrix is first of all a square matrix. So it's 2 by 2, 3 by 3, 4 by 4, and it has zeros in the lower left-hand corner, ones across the main diagonal, and then zeros on the upper right corner. So a 2 by 2 identity would look like this. Ones down the main diagonal, zeros everywhere else. 3 by 3, 4 by 4, just like that. Okay, and so on. Okay, so the other thing is that when you multiply any matrix by the identity, you're going to get the same matrix back out. So A times the identity is equal to the matrix A. Now, that also works commutatively. So you can go the matrix A times the identity is equal to A, and then the identity times matrix A is the matrix A. Okay, as we know, matrix multiplication is not commutative, so let's give that a try. Let's multiply the matrix -3, 4, 10, and -1 by the identity and see what we get. So we have a 2 by 2 times another 2 by 2. So we're going to get another 2 by 2 out. So again, remember you go row by column. So this is going to be -3 times 1 plus 4 times 0. Then we're going to go over -3 times 0 plus 4 times 1. And then we're going to move down. And then we get 10 times 1 plus -1 times 0. And then we move across 10 times 0 plus -1 times 1. If we do our simplification, we wind up with -3, 10, -3, or excuse me, 4, and -1. Okay, so that's the identity. Now, a matrices inverse. Okay, so let's say we have a matrix A, we multiply it by its inverse, we're going to get the identity out. Now that should work for left-hand multiplication and right-hand multiplication. So the multiplication by an inverse will yield the identity matrix. So let's write that down. Now, a couple things that you should know about inverse matrices, okay? First thing, not every matrix has an inverse. Okay? If an inverse, or excuse me, if a matrix does not have an inverse, okay? A couple things are true. One, it is called singular. So a singular matrix does not have an inverse. Okay? The second thing that you should know is if a matrix is singular, how you know it's singular is the determinant of that matrix is 0. So a good way to tell whether or not you're dealing with a matrix that has an inverse or not, calculate your determinant. If it's 0, then it's singular, no inverse. If it's not 0, then you have an inverse. Okay? All right. Another thing to know is to have an inverse, a matrix must be square. Okay? So it must be square. All right. So how do we find an inverse? Okay, so for a 2 by 2 matrix, we're going to use a formula. For a 3 by 3 matrix, I'll show you in another video how to use the calculator. Okay, and there is a way to do a 3 by 3 and larger inverses by hand, finding the inverse, but we're not going to get into that today. Okay, so for a 2 by 2, matrix, we're going to call it A inverse will be equal to 1 over the determinant of A times, so this is scalar multiplication, D negative B negative C A, where A, the original matrix, is equal to A, B, C, D. Okay, so this is much easier to do if you have numbers. So we're going to do a couple of examples, and I'm going to show you that if we multiply these two matrices together, we do arrive at the identity. So first example, find the inverse of okay. Okay, so our first matrix is 3, 2, 4, 5. Okay, so this is A, this is B, C, and D. Okay, first we find the determinant. Okay, remember that determinant is the major minus the minor diagonals. So that's going to be 3 times 5 minus 4 times 2. So 15 minus 8 is 7. Okay, so when we find the inverse, we're going to go 1 over 7. That's a scalar on the outside. Okay. A and D are going to trade places. So it's going to go 5 and 3 on the diagonal. And then B and C are just going to change signs. So it becomes -2 and -4. Okay. To complete our process, we multiply through by our scalar. So 5/7, -4/7, -2/7, and 3/7. Okay, so that's our inverse. Now what we're going to do is I'm going to show you that A times the inverse that we found is actually the identity. Okay, we should do this with a left-hand multiplication and a right-hand multiplication, but I'm only going to do one. Okay, so the original A, 3, 5, 2, 4. Okay, and don't freak out about the fractions. They're going to resolve out. Okay, because I know it's really, really scary with all those fractions, but it actually works out really nice. So we have a 2 by 2 times another 2 by 2, which means we're going to get a 2 by 2. So, okay, 3 times 5/7 is 15/7. And then add that to 2, -2 times a 4, so that's -8/7. Now we're going to move across. Now we're going to move down. And then across. Okay. Now, I almost never reduce my fractions when I do these because it kind of keeps the same denominator. Okay, so we have 15 minus 8 is 7/7. -6/7 plus 6/7 is a 0. 20/7 minus 20/7 is a 0. -8/7 plus 15/7, that's 7/7. Now, at the very end, I simplify. And there's my identity. Okay, so we're going to do one more example of finding the inverse of a 2 by 2. And in the second video about this, what we'll do is we'll find the inverse of a 3 by 3 on Desmos. Okay, now please note that Edgenuity does have a matrix calculator within Edgenuity, and it's actually pretty good. So you might want to use that instead of Desmos. I just want to show you how to use another resource. Okay, let's do another example. So find the inverse of B, and let's do -1, 3, -4, 8. Okay, so the very first thing we're going to do is we're going to find the determinant to see if I actually have an inverse. So we're going to do major diagonal minus the minor. So -1 times 8 minus -4 times a 3. So -8 plus a 12, which is 4. Okay, so that's my determinant. Since it's not 0, I can invert my matrix. Okay, so we're going to go the inverse 1/4. -1 and 8 are going to switch. Okay, and then 3 will change to a -3, and 4 will change to a +4. Now we're going to do our scalar multiplication. 1/4 times 8 is 2. Remember, you're distributing everything in the matrix by the scalar. Then negative 3/4. Then 4 times 1/4 is 1. And then negative 1 times 1/4 is negative 1/4. Okay, and that's how you find the inverse of a 2 by 2. So now we're going to show that it's true. Okay, so on the last one, we did the original matrix times its inverse. So on this one, I'm going to go inverse times the original. Okay, so we're going to go 2, 1, negative 3, 4, negative 1/4 times the original. And we're going to see if we get our identity. Okay, here we go. Okay, 2 times a negative 1, negative 2. Negative 3 times a negative 4, that would be positive 3, because the 4's cancel out. Now we're going to move across. 2 times a 3 is a 6. Okay, negative 3/4 times an 8 is actually a negative 6. All right, now we're going to move down. 1 times a negative 1 is a negative 1. And then a negative 1/4 times a negative 4 is a positive 1. Okay, and then we're going to move across again. So 3 times 1 is 3. And then negative 1/4 times a positive 8 is a minus 2. And then we simplify. And there we go. We're back at our identity. All right. So the next video we're going to do is we're going to do inverses of a 3 by 3, but we're going to be doing Desmos.